All right, guys, here we go. As promised, a little review session to help you out with the unit test you're going to have this week. You can hear the dogs are barking in the background. That's awesome. We'll just kind of push through all those extra distracting at-home noises as we roll through this. Okay, so what I'm going to do is I want to take you through problems that you're going to see on your test. Not the problems, but the types of problems you're going to see on your test. So what we're going to do is we're going to start with solving. And one of the things you need to remember about the solving piece is that you sometimes will be asked to write your solutions in terms of all solutions. Okay, so that is possible that you're providing all general solutions. Okay. That's going to be fun. And then it could be possible also that you are going to be looking for solutions between 0 and 2 pi. Okay, so if your theta is between 0 and 2 pi, that would be something to watch out for. Probably up to and not including 2 pi is how it will be phrased. Okay, so let's go for this here. As always, guys, when we are working on any kind of problem that you guys are watching me work through, a better choice is going to be to try it on your own first and then go from there. Okay, maybe watch or maybe just look for the solution. And if you think of any questions along the way, please let me know. Okay, so I left you this little note up here about getting your homework done. So there are a lot of please, please, please in it and a lot of practice, practice, practice in it that you see right there. So, so please do that and know that we are also, as you work through any kind of a task that I'm trying to help you prepare with, make sure you work through it on your own to the best of your ability and then go back and check the answers, check your answer keys, and also be prepared to ask questions in class this week. Okay, here we go. So solving, we're going to do one with tangent here. And one of the first things that I'm going to think about is if I'm thinking about, and we're going to go ahead and do all general solutions for this problem, and we're going to go ahead and do solutions between 0 and 2 pi for this problem that's right next to it, okay? And when I think about all general solutions, I know I'm going to have to add the period of the function. And the period, remember, can be found by taking 2 pi and dividing it by our b value. So one of the first things I kind of look for is identifying what that b value is. So at the end of all of this good work that we're about to do, I'm just going to rewrite that as 1/3 of theta, that we have the correct period that we're going to be adding or subtracting to represent all general solutions. So my little 1/3 over here, so 2 pi divided by 1/3 is going to be the same as multiplying by that reciprocal. So we're going to get 6 pi n plus and minus that as the period that we're going to be adding. Now, question for you. Typically, the period is 2 pi divided by b. That would be true if we were going to be using sine and cosine, okay? But I look back over here and I'm like, oh no, hey, that's tangent. That's tangent that I'm using on this function. So don't forget that if your equation is going to be working with tangent, that to find the period you want to take just pi divided by b. Okay, so instead, because this is going to be true for our tangent functions, instead we're going to have a plus and minus 3 pi n. Okay, or pi divided by 1/3. Okay, there we go. So be mindful of which function you're using as you're solving and what you're adding as the period. Super important. Okay, let's get going on this one. We're going to divide both sides by 4. Okay, and as we move on up here, so we have a little more space to work, we're going to get the tangent of 1/3 theta plus pi over 3 is equal to √3/1. So we're looking for the inverse tangent. Where is the tangent? √3/1. So I always think about this in terms of, I'm looking for where the sine is √3/2 and the cosine is 1/2. And so sine √3/2, cosine is 1/2. Tangent is positive in the first and the third quadrants. So I'm looking for answers of pi over 3 and then third quadrant, right? So 4 pi over 3, those are going to be my two values that have a tangent of √3/1, sine over cosine. All that is still equal to 1/3 theta plus pi over 3. Okay, so let's go ahead and keep working towards getting this value of theta by itself. What you're going to see with the tangent function is probably, because we're going to be working with tangent, it has that special thing that when we add the period, the answer that I get here is going to be kind of overlapping or similar to the answers that I derived from this other solution. But we're just going to go ahead and do them both. And if you give me both of them, that would certainly be better than giving me missing one, right? So this is kind of a nice way to tackle this problem. So we're going to subtract pi over 3 from both sides and multiply by 3. So on this side we get 0 is equal to theta. Over here, if we subtract pi over 3, we get 3 pi over 3. Okay, and if we multiply that by 3, right, we just get 3 pi is equal to theta. So if you need to do a little bit more algebra right in between there to do that, just remember what you're doing is you're subtracting pi over 3 and then multiplying by 3 to clear the fraction. And then our answers are going to be 0. And look at this. Look what has happened. 3 pi plus and minus 3 pi n. So we can see if we subtract 3 pi n, we get back here to our answer of 0. And it looks like all of our general solutions then could be expressed as basically 0 plus or minus 3 pi n. Okay, so that's it for that one. Let's move over here to the right. Now, what I'd like to do on this one is I'm going to kind of get started. I'm going to get you started, and then I'm going to stop recording, kind of work through the rest of the solution, and show you guys the answer at the end. Again, for this particular problem, we're trying to figure out the answers between 0 and 2 pi. Okay, there's a lot going on with this. I want to isolate my sine expression, my trig expression right here. So I'm going to start by adding 5 to both sides. What that looks like over here is I'm really adding 15/3, right? Because that's the same as 5, and I get a common denominator and make that work out nice. So we have 1/3. Again, we're just going to get kind of rolling together here. Minus 3 theta plus 2 pi over 3 is equal to a negative 1/3, right? As we combine that negative 16/3 with 15/3. And then if we're going to clear the fraction by multiplying by 3, what I'm looking at now is sine of negative 3 theta plus 2 pi over 3 is equal to, it looks like it's going to be equal to a negative 1. Okay, so you guys take it from here. All right, I'm going to do a little work while you guys are doing a little work. We're finding the angle whose sine is a negative 1. And then we're remembering to adjust our period so we can look for solutions between 0 and 2 pi right here. All right. So take this and run with it. In just a minute, all the answers will appear. If you don't want to see them right away, you can go ahead and pause the video at this point, kind of finish this off on your own, and then check your solution at the end. Okay, I'm back. So after working through the algebra and figuring out that the angle whose sine is -1 is 3 pi over 2, I worked through some things and I got this -5 pi over 18 as my value of theta. Now I wanted you guys to remember a couple things, right? That we are going to actually have to add 2 pi over 3n, okay, because my b value is 3. I changed that so it has a common denominator right here, so I'm really going to be adding 12 pi over 18. I don't want to subtract it any further because I'm looking for all solutions between 0 and 2 pi. And then I made a little mental note for myself right over here in the corner about what 2 pi looks like with a denominator of 18. So I gotta get clear to 36 pi. So I'm gonna scroll up just a little bit more here. So we have a little space to add 12 pi over 18 to my value. So what's that gonna be? 7, right? So it looks like we start out by getting 7 pi over 18, and then I just keep adding 12. And so we have 19 pi over 18. And then I'm going to add another 12 pi over 18. So what's that going to make the next one? 31 pi over 18. If I added 12 more, that's going to put me over the top for my target. So those should be your solutions, okay, that exist between 0 and 2 pi. Hopefully that went pretty good for you guys. I have one more over here. I'm going to work through it just off screen, but here's the problem. You guys can go ahead and write it down and see how you might go about solving that, and give it a shot, and we'll come back and see what the answer is. All right, think about factoring on this one. All right. There it is. This would be all of your solutions between 0 and 2 pi, and then I kind of threw in a little answer that would represent all possible solutions. Very good. All right, we're going to kind of zoom on over to this whole solving things, and we're going to take a look at an applied problem. So you will also have an applied problem on your exam. And so it is really, really important that as you're reading through an applied problem situation, that you're able to kind of graphically represent what is happening, and then be able to plug a value in for t, or for your x value, plug a value in for y, or in this case it'll be probably your height of the gum at any given time, and be able to work through the algebra of that. Of course, you can check your answers on your graphing calculator, but you are going to need to show me the work on your algebra. So right now is a great time to practice. So I'm not going to spend a lot of time with the developing the equation or plugging a value of 15.6 in for t. I want you guys to be able to do that. I will draw the picture for you though, and let you know what the correct equation is going to be. And then we're going to dive a little bit deeper into, and I'll go kind of step by step with you through this solving for those 2 times when the piece of gum is 12 centimeters above the ground. Okay. So Lamage is riding bike, and at time t equals 1.25 seconds. So you guys have seen me do this before, where we start kind of taking a look at graphically what is happening with my picture as I'm reading through. Maybe that's 1 second, 2 seconds, 3 seconds, and so on, as I'm reading through this information. So 1.25, there's 1.5, 1.25 will be right there. So I'll just mark that, 1.25. And what's happening? At time 1.25 seconds, the gum was at a maximum height above the ground. And 1 second later, the gum was at a minimum. Well, if we're talking about a bike tire, a maximum height is going to be, you know, the top of the wheel. And 1 second later, so that means at, right, 2.25 seconds, it's at its lowest height, which basically is the ground, if you're thinking about this gum that got picked up off of the pavement to begin with. And then if that is 1 second to go from a high down to a low, then it must be 1 more second to go from the lowest point up to the highest point. So you guys should be well versed at developing this kind of a scenario, okay? Now this looks like a cosine curve to me. I'm going to write it in terms of cosine. I am going to write it in terms of a positive cosine with the amplitude because it's kind of opening up. I have the top point and another top point as opposed to a low point and another low point. But if it was shaped more like this, right, going from the bottom to the top and to the bottom again, then I might write it in terms of a negative cosine, okay, with the phase shift. Just to make it easy on yourself. Okay, a little bit more information. If the diameter of the wheel is 68 centimeters, so that means we're talking 68 centimeters here, find a trig equation that will find the height of the gum in centimeters at any given time t. Okay, so this is where I'm going to stop, and you guys stop, work through the rest of this problem to the best of your ability, and then come back to me. Okay, I'll see you in a few. Okay, ta-da! There it is. So you can see that we have our equation. Double check your equation against that. You can see we've already done part A. The answer is given right here in the cute blue cloud. And then we get to this part B where we're trying to find the different times, right, that algebraically, that the piece of gum is 12 centimeters up into the air. So that's going to be, you know, if we had to draw a picture in terms of graphically what is happening, we're looking for that y equals 12 space right here. And you can kind of double check your work, guys, with your graphing calculator, but I do want you to be able to show me this, this very important algebra. Okay, so here we go. We're going to subtract the 34 and then divide by 34. So what is it going to look like? Let's see. Kind of did some work through here. Didn't have my stuff all together with me. Sorry, I did the whole thing kind of together. So we subtract 34 from both sides, and it looks like we're going to get a negative 22, and then we're dividing by this 34 right here, divided by 34, is going to be equal to the cosine of pi times x minus 1.25. Okay, so this is the part that is going to help you to find the two different solutions algebraically. And it comes from where you take your inverse cosine of a negative 22/34, okay, and set that equal to pi times x minus 1.25. Okay, the other answer you're going to get, right, and I think the cosine inverse of, I think that turned out to be like a negative 0.64070588, okay, some little decimal value that is there. And you're going to go ahead and take that and continue to solve for x. So that's going to help you to find a time. It may not be the first or second time, but it's going to be a time that the gum is 12 centimeters above the ground. Okay, here's the tricky part, right? The other answer you are going to get by taking 2 pi minus the cosine inverse of your negative 22/34 and set that equal to pi times x minus 1.25. Okay, so let's both take a minute to go do some calculator magic, and I'll throw the answers on here in just a second, and you guys can try it as well. And then remember, the period is 2 seconds, right? It's 2 seconds from the top of the wheel to the top of the wheel again. So we're going to use this idea of this going around every 2 seconds when we come back after we have our two values of x, okay? So you guys try it, I'll try it, we'll see what we get. All right, so what do you guys think? This is one of my answers, about 1.9744 seconds. And this is one of my other answers, 2.5256 seconds. The only cautionary thing about this is because 2 seconds is the period of my function, I can subtract 2 seconds from this and probably get the first time that the gum is at 12 centimeters, and that would be at around 0.5256. I might have rounded differently than you guys did seconds. So that should be probably the first time, and then I think this 1.9744 is the second time. And you could verify that on your calculator if you were hoping to have that kind of verified a little bit more. Super important that you remember to include 2 pi minus your cosine inverse of negative 22/34 as the second algebraic way to get that other point at a height of 12 centimeters. Okay. Let's zoom on back. We are done with solving. We have done a lot of work with solving. You guys have tried a lot of solving. That is kind of the scope of what you're going to be doing with solving in your exam. A lot of different solving problems. And then we are going to move on to simplifying and verifying. Okay, so we remember when we simplify problems, we do not have a finish line, right? So we're going to just do a couple of these together real quick, simplifying and verifying. I'll do one, you do one, and we'll move on through the rest of the types of things you're going to see on your exam. Okay? So let me start with this one right here. I see sine of negative x. That looks like an odd even identity. So I'm gonna substitute negative 1 times the sine of x. And then I still have secant of x, tangent of x, which probably I will change to 1 over cosine and maybe sine over cosine here in my next line, but we're going to deal with this odd even and then this cofunction identity right here. Cotangent of pi over 2 minus x can be rewritten as tangent of x. So cotangent and tangent are those cofunctions. So let's see what's going to happen with the top here. Negative sine of x, I'm going to go ahead and put that over 1 since I'm going to change secant to 1 over cosine. And I'm going to change tangent to sine over cosine. And I think I'll just go ahead, since we're on a roll here, and change tangent to sine over cosine as well. See what we end up with. Okay, I'm going to jet on over here to the side a little bit. It looks like I have a sine x times 1 times sine x in the numerator. So it looks like I have a sine squared of x over a cosine squared of x. And that's negative divided by a sine x cosine of x. And it's quite possible that maybe I would just change these back to tangent. You know, you can go ahead and divide by this fraction and multiply by the reciprocal. I guess we can just kind of continue along that vein. Here we go. Let's go ahead and do that. Cosine squared of x times the reciprocal of my denominator, cosine of x over sine of x. I'm going to have 1 cosine that's going to cancel, 1 sine that's going to cancel. And for this particular problem, I'm left with a negative sine x over cosine x, which is equal to a negative tangent of x. Okay, maybe up here, if I had left this as tangent of x, what I could have done instead, and this might have been a lot faster, would be just to cancel the tangent x's. So here's another way I could have gone. right? And then I get sine x times secant x, which is just a negative sine of x times 1 over cosine of x. And if I went that route, I'd immediately be at negative sine x over cosine x, which is negative tangent of x. So in doing this problem in kind of a couple of different ways, you can see that it depends on which route you go. If I went this way to simplify, I got to my answer a lot faster. If I kind of went down this fraction road, it might have taken a little longer, but it really doesn't matter which way you go. The point is you're trying something, right? You have to try something. All right, so take a minute and try this one right here. Tangent squared over secant of theta plus 1, all right? And all we're doing is simplifying. And remember, simplifying is a little scary because you never knew where to stop. Okay, so try this one real quick, and then we'll go to a situation where we actually have a finish line, which I know you guys like. Okay, give that one a shot, and the answer will be up in just a minute. All right, guys, welcome back. This one could have gone in a lot of different directions for you. One of the things that I try to do is if I see that tangent squared with the secant is I try and think about those Pythagorean identities that we've been talking about so much. Like, hey, what is that? Wasn't there a Pythagorean identity with tangent squared and secant? So here it is, right? So what I did is I subtracted 1 from both sides. And then I took this tangent squared theta and I replaced it with secant squared theta minus 1. The reason for doing that is I was kind of looking ahead and thinking, maybe we can factor this into difference of squares. So that in fact does factor into the difference of squares right here. And then what is nice about that is I kind of was looking at the bottom of my fraction and noticing that I had a secant theta plus 1 already here. So those two are going to cancel now that this is tied just with multiplication. That leaves me with a secant theta minus 1. I add 1. Simplifies a little bit further just to secant theta. And that's where we're going to stop. Okay? So maybe you went down a different path on that. Totally okay. Totally okay to go down a different road. All right. Verifying. Da, 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 da. Loving this because we actually have a finish line. You will have a couple verifying problems. You like to have that finish line. All right. So here they are. If you guys would like to just stop the video and try them, you're certainly welcome to do that before I kind of move on. I'm going to go ahead and jump into this first one and kind of talk my way through it. And then, of course, on the second one, the answer will just appear, okay? Just kind of to save a little time. Okay, so we have a lot going on here. One of the things I'm looking at is, as I'm looking at this first problem, is the finish line has things in terms of sine and cosine right over here on the right side. So I think what I'm going to do is I'm going to change everything to something in terms of sine and cosine. So I'm going to change the tangent to sine squared of x over cosine squared of x. I'm going to leave the 1 alone for just a second until I kind of see what's happening here. I'm going to change tangent to sine of x over cosine of x. I'm going to change secant to 1 over the cosine of x. And remember, we're not changing the right side. We're just trying to manipulate this left side to make it look like that right side. So let's see what I have. I have a sine squared, I have a cosine squared x. Let's see, let me rewrite this again. Sine squared of x over cosine squared of x. So that denominator is a cosine squared of x. I'm going to change this 1 to cosine squared of x over cosine squared of x. And the reason for that is I'm looking at this combination of these two fractions here, seeing that that is going to come together to be sine x over cosine squared of x. So that's handy because now I have a common denominator, and look at what I'm shooting for at the finish line, cosine squared of x in the denominator. So that's looking pretty good. Okay, so let's see what we have on the top. So on the top we have sine squared of x plus cosine squared of x plus sine of x all over cosine squared of x. Now, this is the part where you should be recognizing that sine squared of x plus cosine squared of x, that super duper little identity right there, can be replaced with a 1. So I'm going to take that out, I'm going to put a 1 in its place, and I'm going to see if that seals the deal at our finish line. So let's see what happens here. Oh yeah, hey, now I've made the left side look like the right side, right? I've made it look like this, our finish line up here. Okay, perfect. So hopefully talking through that kind of helps with some of the thinking. Go ahead and try this next one, and I will share with you that what I would try, okay, as you're trying this next verifying an identity, is I would change tangent. Okay, so let's just do that first part together. So let's get started together here. Cosine of x over 1 minus the sine of x. And I'm going to subtract sine of x over cosine of x. So I have this fraction, and this whole fraction, I'm trying to make it somehow look like secant of x. That's my finish line. So what I'm going to try, I'm going to put you guys to work on this, and I'll be back and the answer will just magically appear. Get a common denominator. Okay, that's going to mean multiplying this fraction by cosine x over cosine x. That's going to mean multiplying this fraction by 1 minus the sine of x over 1 minus the sine of x. Okay, take it from there and see how you can finish it out. Remember, you're shooting for the finish line right here. This is your finish line, making everything look like the secant of x. All right, good luck. And there it is. Were you guys able to get to that? You might need to pause it and maybe take a look at it. If you need to, that's okay. A key on this one was this little negative sign back in here, because you had to multiply that negative sine x times and through your parentheses. And then I kind of highlighted your identity right here. The sine squared of x, cosine squared of x gets replaced with a 1. These canceled, and 1 over cosine x was your secant of x. All right, there you go. Verifying identities, simplifying identities, solving. All done. All right. You will have some problems like these. Give these a try. These are the kind of problems, remember, that we were working on, where you would look for the angle whose cosine is 5/13. So we're looking at something like this, right? The adjacent over the hypotenuse is 5/13. You're using a little Pythagorean theorem, right? A squared plus b squared equals c squared to solve for the third side. In this case, it is a Pythagorean triple. And so the cotangent, because the cotangent of your angle is equal to the cosine over the sine, our answer for this particular problem looks like it is going to be 5/12. Hopefully that's what you guys got. Hopefully you stopped this and tried it before you got to the answer. This one is going to be a little trickier. Our 2x is not a fraction, so we're just going to make it 2x over 1. So we are going to go ahead and draw that right triangle. Again, make sure you stop this video if you want to take a minute to try this on your own. I think that's a great idea. So let's see. The angle whose sine is 2x means the opposite over the hypotenuse is going to look something like that. I'm going to go ahead and use Pythagorean theorem here to write an expression for this third side. Again, our reference angle is, we'll just call it angle theta right there. So it looks like we're going to have a is equal to the square root of 1 minus 4x squared. Okay, so this third side, 1 minus 4x squared. Beautiful work there, guys. And the cosine of that, okay, is going to be adjacent over hypotenuse. So our answer for this particular problem is just going to be my 1 minus 4x squared. All right, what if you wanted the, let's play around with this one a little bit more. What if you wanted a, oh, look at him come on, right on. Hey guys. Look at him welcoming you to the next page and graphing. If you did something like cotangent of the angle, then you would have adjacent over opposite, and you would write your answer just as a fraction, guys, like 1 minus 4x squared all over 2x. Okay, and just leave it like that. Okie dokie. The graphing piece. Okay, so I actually posted another video on graphing that I thought was really, really nice. I just want to remind you that you should know how to graph just your inverse sine function and your inverse cosine function. Cosine inverse of x. Okay. And remember that for inverse sine, you are graphing from negative pi over 2 to pi over 2. And for cosine, you're graphing from 0 to pi. So maybe try just working through creating these graphs. And remember, with the inverse sine function, we're going to have our numbers, like 1, 2, 3, happening along your -1 x-axis, and then we're going to have your numbers in terms of pi along your y-axis. Okay. So let me get these drawn for you real quick, and I'll be back and we'll just talk about them. And then really I would like you to watch that other video because I think it does a nice job of transformations, like just moving and sliding your graphs around the coordinate plane. Okay, we'll be right back. Well, there you go. A few inverse functions for you guys to kind of ponder. One of the things I like to do is I like to sort of make a graph of my sine function, and then pick these kind of key points, and remember the inverse sine, you're going to be just switching out your x and your y. So I kind of just showed you switching out your x and your y from your original parent function for both sine of x and cosine of x. So there are lots of different ways to kind of think about that, but hopefully that helps to see those inverse functions again, and we can practice them in class as well. And then the very last piece is going to be this little navigation problem. So lock it down, try this problem. It's pretty much just straightforward right triangle trig, all right? But here's a chance to practice and then also see the correct answer. So go ahead and stop it. I'm going to draw some things, and then we'll come back and talk about how we answer the question, how far east and south is the yacht after 12 hours? All right, give this one a go. Magic, and just like that, been busy calculating distances east and distances south. So you can see that I used my 88.6 here. Now you could, switch up things and use your 1.4 degree angle that is right here, and again, create your triangle a little bit differently. So just be careful that you're being mindful of how you report your answer on this. So I would say that they have traveled east, and because that angle of that they're traveling along, south 1.4 degrees east, is so tiny, we've only traveled about 5.86 nautical miles to the east, and to the south, quite a few more there. 239.93 nautical miles to the south. And hopefully you guys got the same or similar kind of answers. Whenever I'm doing story problems, I was busy, writing the information. The speed of 20 knots for 12 hours meant we were going 240 miles, which is why that became part of our calculation right here on this hypotenuse. Right, so hopefully that went well for you guys. All right, that's it. Kind of a long video. Hopefully you guys were able to take this and kind of chunk it out a little bit and practice. But those are the types of problems that you will be seeing on Friday. Okay, good luck. Study hard. I will see you in class.